Hi, today I'm going to talk about the experiment, Instrument 2 of our electronic lab. This lab contains 7 experiments. Let's start with the first one. Experiment 1. Operate the function generator and adjust it as requested. You have to know how to adjust the settings of the oscilloscope in order to show the waveform clearly. Change the coupling switch from DC to AC and observe the difference. Set the function generator to generate signal of approximately 1 Hz. Change the scale of time axis. You'll see the figure changes. Set the oscilloscope input coupling to AC and make the function generator output signal from 10 MHz to 60 MHz. Note that this is high frequency signal, so the circuit configuration between the function generator and oscilloscope will change the waveform. This change is related to the RLC circuit oscillation. Try to explain this phenomenon to your TA. We will give you bonus scores according to your understanding. The oscilloscope drawing speed is related to the frequency of the input signal. When observing the 1 Hz signal, because it is a low frequency signal, you may see the oscilloscope draw the signal from left to right. On the other hand, when you are observing the 1 MHz signal, you may see the signal shifting left and right very fast. This is because the drawing of the oscilloscope is very fast at high frequencies. Therefore, we have to use the concept of trigger to make the signal still. Experiment 2. Observe the signal of main and sink at the same time and write down their relation. You can try to change the waveform, frequency, amplitude of the main and see how does the sink signal change. Experiment 3. Generate a signal as requested. Note that the duty cycle is 80%. This will make the signal look like this. Use AC and DC coupling and observe the average of the signal. Plot the figure and draw the location of trigger and average. When drawing the figure, you don't have to draw it precisely, as long as the key points are recorded inside. You may figure a way to draw it efficiently. Remember to indicate the trigger level on the paper. Here we'll clarify some words that are often confusing. The peak-to-peak value are the value that is measured from the highest point to the lowest point. The amplitude value shown here is defined as the value from high-level signal to low-level signal. But in this course, the amplitude is defined as half of the peak-to-peak value. So when the TA or our document talks about amplitude, it is different from the one shown on the oscilloscope. I remind you one more time, our amplitude definition is half of the peak-to-peak value, which is different from the one shown on the oscilloscope. Experiment 4. In this experiment, you have to construct a small circuit and measure the waveforms from point A and point B. Because of the capacitor, you will see on the oscilloscope that the two signals have phase differences. Measure the phase difference with the cursor function. The capacitor used here is 503. It looks like this. On the oscilloscope, you may see signals like this. You have to determine which is the leading signal and which is the lagging one. In this case, note that I2 is leading because it starts earlier than I1. You can see their relation here. Also, observe when you adjust the trigger level. When you're drawing the figure, remember that you should indicate clearly the position of the important informations, such as the trigger level, which signal is A and B, and so on. Experiment 5. Generate the AM wave with carrier of 800 Hz and modulating wave of 200 Hz. When we modulate a signal using a carrier, it looks like this. One important parameter is the modulation index. It indicates the relative size of the signal in our carrier. In this figure, you can see that the output signal will change its amplitude according to our signal. The amplitude of the carrier is B. It is the average of the highest positive and lowest positive amplitude. The amplitude of our signal is A. The mathematical equation of the AM signal is like this. The amplitude of the AM signal is the amplitude of the carrier signal plus the amplitude of our signal times the frequency of our signal. After some calculations, you will see that the mu here, which is our modulation index, is equal to AM divided by AC. Here's a little reminder. The modulation function is activated when you push the button mod. Experiment 6. In this lab, we're going to measure the resistance of the oscilloscope. There are two ways to do this. One is use the multimeter and test it directly. The other is to use outside resistance. The oscilloscope wire has a red end and a black end. The red end will connect to this wire and have to pass the resistance or the capacitor to reach the ground. So we can use this to make the resistance of the oscilloscope become serial with our output resistance. According to the number of divided voltage, you can calculate the resistance of the oscilloscope. While measuring with your multimeter, do it as this way. Experiment 7. This lab wants you to use the BK precision machine. We'll repeat the experiment from our first lab. Note that the power supply has 3 channels. None of them contains the one to ground. So we will use a wire to connect the ground from outside. Connect it to the oscilloscope ground. This is connected to the endpoint of this plug. Every electric device in the building will have the same ground because they're all connected together. That's all about this experiment. Good luck.